Hello, dear students. You are entering the 10th standard of the academic year 2020 and 21. So, once again, that I want to welcome you for the SLC class. Today, the mathematics subject will be conducted. The first chapter is arithmetic progression. Shortly we can tell AP. Before going to define a progression or arithmetic progression, first we want to know about sequence. So, one day-to-day example, you can tell that a salaried person getting 10,000 per month, every year, that every increment for the year is 1,000. What is the total amount after 20 years? Such examples are related to the arithmetic progression. So, sequence, and there are types of sequence. One is finite, another one is infinite. Just for example, you can take example number 1, 2, 3, 4, 5. 2, 3, 4, 5 and so on. And example number 2, 2, 6, 18, 54. 2, 6, 18, 54 and so on. So when you are observing the types of sequence, here the numbers what you can tell are the terms of the sequence. Here only 4 terms are there, but here we cannot imagine how many terms are there in this sequence. So by observing this, you can tell this is finite sequence and this is infinite sequence. So just for example, these can tell A1, A2, A3, A4 and so on, AN. These are said to be terms of the sequence. Terms of the sequence. So here, just for example, that is AN is equal to 2n. AN is equal to 2n is said to be nth term of the sequence. Where that n gets n equal to 1, 2, 3, 4, they must be natural numbers because we are having numbers, so natural numbers. So for just example, if n equal to 1, a1 is equal to 2 into 1 is equal to 2. n equal to 2, that is a2 is equal to 2 into 2, 4 and so on. You can write that 6, 8, 10 and so on. So here what you can understand by this? 2, 4, 6, 8, 10 and so on. So there are, that is an is equal to 2n is the sequence of even numbers. Yes, understanding? So now just for example, an is equal to 2n minus 1. Where n equal to 1, a1 is equal to 2 into 1 minus 1 is equal to 1. And a2 is equal to 2 into 2 minus 1 which is equal to 3. a3 is equal to 2 into 3 minus 1 is equal to 5. So this also 1, 3, 5, 7, 9. These are also said to be terms of the given sequence. So we can understand here 1, 3, 5, 7, 9 and so on is said to be a sequence of odd numbers. It means you can tell an is equal to 2n minus 1 is a sequence of odd numbers. So similarly we can consider the sequence, nth term of the sequence, an is equal to n square. So here also a1 is equal to 1 square equal to 1. a2 is equal to 2 square which is equal to 4. a3 is equal to 3 square which is equal to 9. What you can tell here? 1, 4, 9, 16 and so on is said to be sequence of square numbers. So these are the definition and some examples for sequence. So now when you are observing the first sequence, that is 2, 4, 6, 8, 10 and so on, and also 1, 3, 5, 7, 9 and so on, and third example 1, 4, 9, 16, all according to definite sequence. So now we are going to define what is sequence. So all these three examples are written according to some particular rule. It means that arrangement of given numbers according to some particular rule is said to be a sequence. So progression. So related to sequence, progression, all are said to be progression, but different types of progressions. So for you people, only there is the progression, that is arithmetic progression. So now, just what you are seeing the examples. Example number 1. So that is 2, 4, 6, 8, 10 and so on. So what we are told that is first term, second term, third term, fourth term, fifth term. Yes, except that first term, we are going to write the remaining terms of the sequence. That what it is? 4 minus 2, which can tell a2 minus a1. 6 minus 4, which can tell a3 minus a2. 8 minus 6, which can tell a4 minus a3. All are 2. So what we can tell about this? Difference. Difference is constant. So difference is always calculated a term and its preceding term, that is a2 minus a1, a3 minus a1, the term and its preceding term and its preceding term. Where there is, it means I can tell that progression is a sequence in which difference between any two conjugate term is constant, or you can tell a particular number is added to the term to get the succeeding term, or subtract a particular number to the from the number to get the preceding term is constant. Then you can tell that is a progression. That progression is said to be arithmetic progression. Yes, I think all of you can understand it. So now some more examples. So let us take some different examples related to sequence. So now nth term of a sequence is 2n plus 1. So find first 4 terms of this given sequence. It means that we can tell n equal to 1, 2, 3 and 4. Is it? So now if n is equal to 1, then a1 is equal to 2 into 1 plus 1 is equal to 2 plus 1 equal to 3. Similarly, n is equal to 2, a2 is equal to 2 into 2 plus 1, 4 plus 1 which is equal to 5. n is equal to 3, that is a3 is equal to 2 into 3 plus 1 equal to 6 plus 1, 7. So n is equal to 4, a4 is equal to 2 into 4 plus 1 equal to 8 plus 1 which is equal to 9. these are the first four terms of the given sequence. n is equal to 2n plus 1. So 3 plus 2 5 plus 2 7 plus 2 9. So constant term, a fixed number is adding to the number to get the next one. So we can understand such types of examples are related to sequence where particularly difference is constant, then it is said to be arithmetic progression. Yes. So now then what is the general form of arithmetic progression? General form of arithmetic progression, that is, let us take that a is first term and d is common difference. That difference is said to be common difference. So now a is the first term. Then that difference is added to the number to get the next number, a plus d. Then the third term, which can we get a number term plus common difference, which you can tell a plus 2d. A plus 2d plus d, which you can write a plus 3d. A plus 3d plus d, which is equal to a plus 4d. It means that is, this is the first term, this is the second term, this is the third term, this is second term, this is third term, this is second term, this is third term, this is fourth term, this is fifth term. So general form is a plus d, a plus 2d, a plus 3d. So this is said to be general form of arithmetic progression, where a is the first one, d is the constant, d is a common difference. That common difference can be calculated. Difference always the term and its preceding term, consecutive terms. So this is general form of arithmetic progression. So now, just for example, first term is 4, common difference is 2, right, and AP. So first term plus common difference, second term plus common difference, third term plus common difference. So that is AP is 6, 8, that is 4, 6, 8, 10. This is said to be arithmetic progression. So just for example, A is equal to 4, common difference is 0. What is an AP? So now 4 plus 0, 4 plus 0, 4 plus 0, 4. So here this is said to be an AP. It means now, and also we can tell that one example, A is first term is equal to 5, common difference is -3. What is an AP? So now 5 plus of 5 is the first term, 5 plus of -3 is 5 minus 3, which is equal to 2. 2 plus of -3 is equal to 2 minus 3 equal to -1. It means that 2 minus 1 is said to be an AP. By observing the examples, difference key may be positive, may be 0, and may be negative. Yes, and also when AP is given, at that time how to find the first term and common difference. So here 5, 7, 9, 11, 13 and so on. So I think all of you can observe that how many terms are to be written when you are writing an AP. Minimum three terms must be required. So now here the first term is 5. The common difference CD or D can tell 7 minus 5 equal to 2. What you can tell the term and its preceding term. The term and its preceding term. So, and another example, 7 and so on. So now, first term is 7 and common difference is 4 minus 7, which is equal to minus 3. Or also D minus 2 minus 1 equal to minus 3. See now, the common difference is constant. So like this we can find out the first term and the common difference for the given AP. So yes, some examples for homework. Find first four terms of an given AP. First one is A is equal to 10, D equal to 10. Second example, A is equal to minus 2, D equal to 0. Third example, A is equal to 4, D equal to minus 3. A is equal to minus 1, D is equal to 1 by 2. And the fifth example, A is equal to minus 1.25, D is equal to minus 0.25. So, second type of examples, for the following AP, APs, write the first term, and common difference. It means you can already discuss. So A is given, D is given. Our work is to find 4 terms. And for the second example, for the following APs means APs are given. Our work is to find a first term and common difference. So example number 1, 3, 1, minus 1, minus 3 and so on. Second example, minus 5, minus 1, 3, 7 and so on. Third example, 1 by 3, 5 by 3, 9 by 3, 13 by 3 and so on. The fourth example, 0.6, 1.7, 2.8, 3.9. It means here, first only in the example they have told, what is that? The given numbers are in AP. Then our work is to find out first, just for example, first term is 3, common difference means the term and its preceding term, consecutive terms, A2 minus A1, 1 minus 3 is minus 2, like that, minus 1 is minus 2, minus 3 minus of minus 1 is minus 3 plus 1 is minus 2, like that would calculate the first term and the common difference of the given AP. So next type is which of the following are AP? Which of the following are in AP? It means that they have given the set of numbers. Our work is that the numbers are in AP or not. So what is the problem there? Our work is to see that according to definition, the difference must be constant. That difference must be calculated term and its preceding term. So that is first example 2, 4, 8, 16. Second example 2, 5 by 2, 3, 7 by 2. And third example 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, and so on. The fourth example 0, minus 4, minus 8, minus 12, and so on. Fifth example 1, 3, 9, 27, and so on. The sixth example is root 2, root 8, root 18, root 32. So what is that? Which of the following are AP? Next part is if they are AP, again write 3 more terms. Which term is AP? Then if they are AP, first work is to find out that AP or not. Just one example I want to tell you. 2, 4, 8, 16. To adding 2 to 4 comes. For adding 2 to 4, 6 comes. It means 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. So that common difference is not constant. So the first example, the numbers are not in AP. Understand? So that is not in AP. No need to write 3 more terms. So second example is like first work is to find common difference between 2 conjugate terms, at least minimum 2 or 3, or you can find out. So after that, if they are constant, then that you can tell in AP. If they are in AP, write 3 more terms. That are common difference added to the number. Can get to the AP. Again 3 more terms. Okay. So now students, I think this is the first lesson for you, and slowly we are going to learn about next part of the arithmetic progression. So this is some ideas about arithmetic progression. Next we will continue the next part of the chapter arithmetic progression. Okay, thank you.